problems. And let me start by saying again that we will, if you like content like this, then please subscribe. We have, as you can see, solved 36 problems, and we are on problem number 37. So let's get on with it. Today we'll try to solve one or two problems depending upon how much time we have. So let's start. We will create a new document. We'll call it problem 37. Problem 37, and let's copy the problem. What the hell? Problem 37, and we'll call this truncatable primes. And let's see. So that's that. Okay. So now let's read the problem. The number 3797 has an interesting property, being prime itself. So this is prime. It's possible to continuously remove digits from left to right. Okay, and remain prime at each stage. So this we remove from left to right. We remove 3. We have 797. So apparently this is prime. So we remove 7. We have 97, this is prime, and we remove this and it is prime again. Okay. Oh, we can also remove from right to left. So we can remove 7 and we have 379, and we can remove 9, we'll have 37, and we'll remove 7 and we have 3, and each of these things are prime. Okay. Find the sum of only 11 primes that are both truncatable from left to right and right to left. So the biggest question is when do we know when to stop? So apparently there are only 11 primes. So I am guessing that we will look at the first 10,000, all primes less than 10,000. That could include this, and see whether we can create a program that will find this as one of its truncatable primes, and if it can, then we will just continuously increase the total number of primes that we look at until we get the right set of primes. Okay, so having said that, let's start. Okay, so so the set of steps that we are going to follow is: 1, we are going to get a set of primes, filter truncatable primes, and that's it. Okay, find the sum. Okay, so add them, and that's the result. So we will just brute force this. Is there something we can do to reduce the number of primes? We'll see that later. I'm not really sure. Okay, so let's start. Let's create a set of primes. So we'll start with 10,000. Okay, and we will get a list of primes that are less than 10,000. Okay, so we've done this before many times. So we will start with an empty list of primes, and we will import numpy. Okay, let's import numpy. Okay, and then what are we doing over here? Oh, finding the primes. Nums is np dot 2 to n plus 1, right? And while nums length of nums is less than is 0, is greater than 0. Okay, we will just take num 0 and add it to primes. primes dot append. We will append the first number and then create a mask. So we have done this like a million times, so it's more or less muscle memory at this point. Nums percentage nums 0 is not equal to 0, so we want to keep those numbers. Okay, then we say nums equals nums mask, and that should give us a list of primes. This about 1,000 primes. It looks about right. Okay, so this looks about right. Do we have 3,700 and something? 3,797. 700 and 3,797. Yeah. So I think we are on the right path. Okay. Now we are going to filter truncatable primes. What that means is that we are going to write a function. We are going to write a function that will tell us if a prime is a truncatable prime. So truncat, I will just call it that. It'll take a number, and I'll assume that it's a prime, and it's going to return a bool. Okay. Okay, so I think it will be easier if we just look at a number and see whether it's a prime. And so let me see, we have to get less and less of these numbers. Okay, so let's convert it into a string. Okay, and let me see. For s in so what I want to do is I want to take different sections of the string. So I will say nstr I only. So let's print this. Okay. And we will type int. Okay. And if I pass in this number 3797, okay, we have a problem. Range length string. Okay, so we are looking at 3797. I think I don't need to look at the first element, because we can assume that the one that we are passing is a prime. Okay, so then if this value, so we go all the way to 797, 97 and 7, and if this value is a prime, if int of that is not in primes, then return false. Okay, so this will look at the first part, and I also want the other thing. Print str minus I onwards. It'll go from the other side, I hope. Okay, so I have 790. Okay, so that's not it. Okay, 379, 37, and 3. So this one also I have to check. All the way to -i. Okay, so if it is not a prime, it's going to return a false. Okay, and this is actually a correct prime. So let's try and check for primes. Okay, so I have a list of primes, and list filter is trunc and primes. 3797. So we have a list of primes. It's a tenth of a second, so it's gonna take a while. So how many do we have? Wait. If it's 2, 3, 5, and 7, it's not considered. So if n is less than 10, return false. Okay, so 23, 37, 57, blah blah blah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. I just need one more. Only 11 primes. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 truncatable primes. I need one more. 10,000, 100,000. Wow, this is taking a long time. Okay, I still have 10. This is the last one. So this is going to take a long time. This one took 10 seconds. This is not good enough. I need to eliminate. Okay, let me see. Wait, this cannot be a truncatable prime. This cannot be a truncatable prime. This cannot be a truncatable prime because 38 is not prime. Huh. Okay, let me filter out primes that have something like this, something like this. Okay. Okay, let's filter out useless stuff. N is of type int, so it's a prime, and it will return a bool true. And so if this contains things like 8, 0, 2, I will get rid of these things. Okay, so let me see. Let me copy some of this stuff. All right, so print nstr I. Okay, if n is less than 0, return true. Don't care, but if 1 onward, then it will return a false. This, if that is in one of these things, 0, 2, 4, 6, 8, 10, and 5, then return useless, otherwise false, and I will call this false. Okay, so given this, I don't think I need to print this. Okay, let me print this and make sure that this is working properly. Okay, useless. Let's put in something like 401. This should be useless, right? 401. Yeah, it's useless. But something like 3797, this is useful. Very good. It looks at 797 and 401. It looks at 3797, 797. It looks at 797, and 401, it's cut short because it already. Okay, so it's doing the right thing. Okay, so then we don't need to print this anymore. All right, and then we have the primes, right? We have 9,000 primes, so we want to find useful primes is P for P in primes if P is if not useless prime. Okay, and so this should come down after this, and let's look how many of these things are there. Length useful primes 800 compared to I think 9,000 length of, yeah, that's an order of magnitude. That's an order of magnitude, more than an order of magnitude. So if I do useful, now useful primes, okay, that's less than a second. Okay, I can accept that time. It's just that I need more primes to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need more primes. So let's go all the way up to 100,000, a million. This is going to take about 20 seconds, 30 seconds, maybe. Wow, this takes a long time. "25 seconds, all right. And let's find the useful primes. Okay, that was fast. 2,543 instead of 78,000. Okay, so this is where it's going to shine. It's 2 orders of magnitude lower. Okay, let's see whether we are able to find useful primes. It's probably going to take 2,000. So used to be about 1,000. Maybe it's going to take 10 times of 23 seconds. Oh, okay. So I think we have 11. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Did I not save these things? I'm going to cheat over here. All right, so that should be the answer. Let's check. Okay, so we have solved one more. So thank you for watching this video, and if you would like to continue watching such videos, please subscribe, and I will see you in the next video.